Now, let us discuss the various types of temperature scales that will be used here in physics. Let's start with the most familiar temperature scale, which is commonly used all around the world, which is the Celsius scale. So the Celsius scale is formerly known as the centigrade scale, and this is named after its developer, Anders Celsius. Okay? At hindi siya kailanman pwedeng pumunta sa ibabaw kasi siya ay laging Anders. Lagi siyang nasa ilalim. So in the year 1742, Anders Celsius developed this temperature scale. So why was it formerly called the centigrade scale? Temperature scales are usually based on reference temperatures. In the case of the Celsius scale, there are two reference temperatures used. First is the ice point, or more popularly known as the freezing point of water, which is 0 degrees Celsius, as we all know, and the steam point or the boiling point of water, which is 100 degrees Celsius. Now, why was it called the centigrade scale? Because from 0 to 100, we know that there is a difference of 100, right? Here are the two reference temperatures. The freezing point of water marked as 0 degrees and the boiling point of water which is marked as 100 degrees. Now, from 0 to 100, this was divided into 100 equal intervals. And one of these 100 equal parts is called a 1 Celsius degree. Sir, bakit yata ang ginamit mo dyan ay 1 Celsius degree, not 1 degree Celsius? Let me tell you a convention. When we write the temperature measurement, for example, 10 degrees Celsius, this is a temperature measurement. But if we're talking about temperature difference or temperature interval, we write it as Celsius degree, no? To distinguish that this is a temperature measurement and this is a temperature interval, okay? So in the Celsius scale, 1 Celsius degree is equal to 1 of the 100 equal parts here. Kaya sa tinawag na centi. Okay, why? Because here, the prefix centi means 1 over 100. Para bagang yung centimeter. Okay? 1 centimeter is 1 over 100 of a meter. Naiintindihan po ba? So, that's the reason why tinawag siya na centigrade. At ngayon nga, pinalta na ng Celsius kasi nga ipinangalan kay Anders Celsius. Now, ano naman ang ibig sabihin ng ice point? Okay, so this ice point of water, which is labeled as 0 degrees, is defined as that specific temperature wherein ice, which is solid water, and liquid water can coexist together in thermal equilibrium, no? At standard atmospheric pressure. Okay, I repeat, ice point is defined as the temperature at which ice and water are in thermal equilibrium at standard atmospheric pressure. Ibig sabihin pala, kung standard atmospheric pressure, no, which is yung normal na pressure na nararamdaman natin, no, kung ganon ang pressure, dapat sa temperature na ito at 0 degrees, pwedeng magkaroon ng thermal equilibrium ang ice, no, which is solid water, at yung liquid water. So that means at the ice point of water, water can be in the liquid phase. Yes. And also water can be in the solid phase. Yes. Actually, that is the temperature at which the liquid water will start to freeze and become solid. Now, ano naman yung steam point? No? Igagaya natin yung definition ng steam point doon sa ice point, no? Parang same lang sila ng format. So we define the steam point as the temperature at which liquid water and the gaseous phase of water, which is steam, are in thermal equilibrium, again, at standard atmospheric pressure. Kung standard atmospheric pressure, yung nararamdaman nating pressure, kapag daw ang temperatura mo ay 100 degrees, then nag-exist in thermal equilibrium ang tubig na liquid at ang tubig na gaseous, which is yung steam, no? And as a matter of fact, this is the temperature at which the liquid water starts turning into steam. Nakakaunawaan po ba? And likewise, yung steam, Kung gusto niyo namang mag-liquid water, kapag siya ay nag-condense, ito rin yung temperature na yun. Ano? So kung gustong mag-condense ng steam, in order to become liquid water, yun ay nangyayari din sa temperature na ito. No? Parang kagaya rin sa ice point. Okay? Kung yung solid ice, gusto niyang mag-melt para siya ay maging liquid, that takes place at this temperature, 0 degrees. Okay? Again, provided we have standard atmospheric pressure. Sir, anong ibig sabihin nun? Kasi kapag nagbago ang atmospheric pressure, hindi na siya yung standard, possibly, ang tubig, liquid water, will no longer freeze at exactly 0 degrees. And likewise, when the pressure is no longer equal to the atmospheric pressure, liquid water will not boil at exactly 100 degrees. Kaya sinasabi natin, kasama sa definition ng ice point at saka steam point na dapat ang pressure ay standard atmospheric pressure. Okay, so I hope that's clear. Now, as I have mentioned, this Celsius scale is used popularly in a huge majority of countries around the world, except in the United States. Why? Because in the United States, they are still using the Fahrenheit. Yang Fahrenheit na yan na dinevelop ni Daniel Gabriel Fahrenheit ay isa pang temperature scale kung saan ang reference temperatures pa rin ay steam point at saka ice point of water. However, in the Fahrenheit scale, these two points, no, the ice point of water and the steam point of water have different values. Okay? In the Fahrenheit scale, the ice point is at 32 degrees while the steam point is at 212 degrees. So let me show you a thermometer showing these temperatures. Here is the freezing point of water. Again, this is the same as the ice point. Now, this is labeled 32 degrees. And also, we have the steam point, which is now labeled 212 degrees. You can see here that there is a temperature, negative 40 degrees Fahrenheit. Why is this significant? Because this is the temperature in Fahrenheit that has also the same value in Celsius. So that means that negative 40 degrees Celsius, let's write it down, the negative 40 degrees Celsius is the same as negative 40 degrees Fahrenheit. Tandaan natin ha, trivia yan. Okay? Now, as I have said, ito nga ay ginagamit sa United States. No? Kaya tayo hindi masyadong familiar dito kasi nga ang ginagamit natin ay Celsius. No? Kapag binigyan ka ng temperature in Fahrenheit, parang hindi mo ma-imagine kung gaano siya kainit or kalamig. Bakit? Kasi hindi tayo sanay. Sanay tayo sa Celsius. Nagkakaintindihan po ba? So now, after having learned this temperature scale, we should be able to convert from one unit to another. Halimbawa, from Celsius to Fahrenheit and from Fahrenheit to Celsius. Kinakailangan matuto tayong mag-convert. So for us to do that, we should be comparing these two temperature scales. So here is the Celsius scale and here is the Fahrenheit scale. We know that the reference temperatures of these two scales are the same. The freezing point of water, which is labeled 0 in Celsius, and now it's 32 degrees in the Fahrenheit. No? How about the upper reference temperature? Here we have 100 degrees in the Celsius and 212 degrees in Fahrenheit. In order to relate them, we need to subtract these upper and lower reference temperatures. Unahin natin yung Fahrenheit. Bakit? Kasi sa Fahrenheit, mas malaki yung difference. Now, what is the difference between 212 and 32 degrees? So, that will give us 180, right? So that is the change in the Fahrenheit. So that's equal to 180. And divide it by the change in Celsius. So in Celsius, the change is 100 because 100 minus 0 is 100. So let's indicate that, no? This is now delta TF over delta TC, no? And delta TF is 180 and delta TC is 100. So we can now relate these two, no? Using this ratio and proportion, no? Okay. So delta TF over delta TC is 180 over 100. Now, parang BP lang ano? Parang BP na high blood pressure. Now, kapag kinuha na natin yan ng lowest term, magiging 9 over 5 yan. 'Di ba? From that, magkakaroon na tayo ng relationship, no? Ito na ngayon ang equation na nagre-relate doon sa Fahrenheit at saka sa Celsius. So, delta TF is equal to 9/5 times delta TC. Now, what if we are given a certain temperature in Celsius and we want to convert that into Fahrenheit? We can see clearly here that 0 degrees Celsius is equivalent to 32 degrees Fahrenheit. If my temperature is 0 degrees Celsius, automatically that's 32, right? But what if my temperature is not 0? It is something above 0. Okay? Then we have to add 32 right away. Okay? Bakit? Kasi hindi sila pantay eh. Ito nagsimula sa 0, ito nagsimula sa 32. Kaya kung ano man ang temperature na given sa Celsius, kinakailangan may 32 agad doon, no? Kumbaga, doon sa magsisimula, may baseline ka agad na 32. Okay? So, dapat lagyan natin ng 32 agad yan. 32 plus, now, anong relationship ng Fahrenheit at Celsius ngayon? So, gusto nating malaman yung TF, no? Itong TF. So, that's 9/5 times TC. Okay? That is why, lalagay ko dito yon 32 plus, ano yung relationship nilang dalawa? 9/5 times TC. Okay? So, this is now the formula for finding the temperature in Fahrenheit. Okay? So, we have 32 plus this relationship, 9/5 times TC. So, from this equation, we can now solve for TC if we want to get the temperature in Celsius if we are given any temperature in Fahrenheit. That would be TF minus 32 multiplied by 5/9. Okay, so this is now the temperature in degree Celsius. Okay, if we are given the temperature in Fahrenheit. Okay, so you should memorize this, no? Now, kung hindi mo naman siya ma-memorize, tingnan mo lang to, no? Kaya mo na siyang i-derive kagaya nung pagkaka-explain ko. Now, we know that these thermometers make use of certain materials. For example, a thermometer has mercury inside of it. Or a thermometer could use an alcohol instead of mercury. And we know that these materials have different expansion properties. That is why these thermometers also have limitations. Okay? Thermometers are calibrated by placing them in thermal contact with reference systems. So, these reference systems are highly accurate thermometers. That is why they serve as reference systems. Now, these thermometers, the usual thermometers that we have, will be calibrated or be measured against the reference systems. Okay? Ika-calibrate natin ang mga thermometer na nabibili natin. They are being calibrated in accordance with reference systems. However, as I have mentioned, different thermometers use different types of materials. And we know that these materials have different expansion properties. And because of that, errors may occur when we measure temperatures. For example, I am using a mercury thermometer. I measured the temperature of an object. I measured this. Okay, this is my measurement. Now, I will use another thermometer, for example, an alcohol thermometer, and measure the temperature of that same object. Now, it's possible that I may get two different values having slight discrepancies. Okay, so these discrepancies are the errors that I am referring to. Why? Because alcohol and mercury have different expansion properties. So that is why errors are generated whenever we measure temperatures. But in most practical cases, these errors are negligible. Kung hindi naman sobrang crucial yung calculation, pwede nating palagpasin yung mga maliliit na error kumbaga. But still, there are errors. And these errors are very important when it comes to scientific research and measurements. Whenever we need the highly accurate measurements, kinakailangan maiwasan natin as much as possible ang errors. Ano pang pwedeng panggalingan ng errors? Yung limitation ng mercury, halimbawa, mercury thermometers cannot be used below the freezing point, no? So, why is this 39 degrees? This should be negative. So, mercury freezes at negative 39 degrees Celsius. Mercury thermometer is useless once the mercury has been frozen. So, hindi mo na siya magagamit at temperatures below negative 39 degrees, right? And likewise, for alcohol, this alcohol has a low boiling point. It boils at 85 degrees. So if you're measuring high temperatures, then an alcohol thermometer would not be useful. Okay? So these are some of the things that add to the limitations of thermometers. Because of the dependence of temperature measurements on the materials that are being used, then there is a need for universal thermometers. Bakit? Kasi nakita natin dito no, na itong mga thermometer pala na ito ay nakadepende yung kanilang expansion properties dun sa material na ginagamit nila, na alam naman natin iba-iba. Kaya nagkakaroon tayo ng error. So, because of that, there is a need for us to have thermometers na pag nag-measure ng temperature ay yung measurement hindi nakadepende doon sa mga properties ng mga materials. That is what I'm trying to say. Again, because of the dependence of the temperature measurements on the materials used, there is a need for universal thermometers whose readings are independent of the materials used. Sir, may alam ka bang ganyang thermometer? Yes, no? One such thermometer is what we call the constant volume gas thermometer. From the name itself, nung thermometer, we may realize that this thermometer makes use of a gas which is maintained at a constant volume. So, in a constant volume gas thermometer, the temperature is determined from the pressure variation of the gas. Oh, so that's it. Mayroong relationship ang pressure at saka ang temperature, no? If we keep the volume of the gas constant, what do you think will happen to the pressure? Parang imaginein mo yung pressure cooker, no? Yung pressure cooker, kapag iyong sinarahan, yung volume ng gas sa loob, hindi magbago. Bakit? Kasi yung pressure cooker mo naman ay hindi nag-expand too much, no? So we can assume that the gas inside the pressure cooker has a constant volume. If you keep on increasing the temperature, what do you think will happen to the pressure of the gas inside? Kaya nga siya tinawag na pressure cooker Kasi yung pressure, pag pinainit mo ng pinainit ang pressure cooker ay tumataas din. Kaya madaling naluluto ang iyong bulalo. O kaya ang nilabong mais. Okay? So that's it. No, we have to establish the relationship between pressure and temperature. Why? Because in that way we can measure temperature, because we know how it is related to the pressure. Now, in the case of a constant volume gas thermometer, we can measure the temperature if we know the pressure variation. Why? Again, we know that this temperature and the pressure are related. Pag tumaas daw ang pressure, tataas din ang temperature. So if I know the pressure, I can also know the corresponding temperature provided that you know the relationship. Naiintindihan po ba? Sir, ano ba ang relationship ng pressure at saka ng temperature? Kung ang volume ng gas ay constant, so that relationship is a direct relationship. Okay? So the pressure is directly proportional to the temperature. Okay? So, ayan. Alam na natin yung relationship. Ano bang itsura ng constant volume gas thermometer na iyan? Ito siya, no? So, if you can see here, we have a glass tube. In that glass tube, we have a gas, no? For example, we call this gas P, no? It's inside the glass tube, which is placed in a bath or an environment whose temperature is to be measured. Then here, we also have a mercury, no? We have a mercury reservoir here containing mercury. So, what will now happen? This gas has a volume that needs to be kept constant. Okay, so let's read it from here. So, the volume of the gas in the flask is kept constant. How is that kept constant? By raising or lowering the reservoir B. So, this is your reservoir B. In this reservoir, the level of mercury will rise or will be lowered depending on the temperature variation. Okay, so here we will have a variation in height. And that variation of height is equivalent to a certain variation in the pressure. And if we know the relationship between pressure and temperature, we can convert pressure variations directly into temperature. So that is how the constant volume gas thermometer can measure temperature. Naiintindihan po ba? So once again, the pressure of the gas inside this thermometer is directly proportional to the temperature. Now, what is the significance of a constant volume gas thermometer? Okay, we can think of this thermometer as an ideal thermometer. And because of that, with the use of this constant volume gas thermometer, an absolute unit of temperature was developed. Unlike Celsius and Fahrenheit, hindi sila absolute temperature scales. Anong absolute unit ang aking tinutukoy dito? Actually, I am referring to the Kelvin scale, which I will discuss in the next slide. But before that, sir, bakit hindi ako masyadong nakakakita nitong mga constant volume gas thermometer na ito? Hindi mo talaga siya usually makikita. Bakit? Kasi they are very bulky. Gas thermometers are impractical for everyday use. They are bulky and they are very slow to come to thermal equilibrium. Now, saan sila useful? These gas thermometers are used principally to establish high precision standards and to calibrate other thermometers. Di ba sinabi ko sa inyo kanina in the previous slide, the commercially available thermometers are being calibrated against reference thermometers. Ito yun, no? Ito yung isa sa mga reference thermometer na ginagamit na pang-calibrate ng iba pang mga thermometer. Nagkakaintindihan po ba? Is that clear? So now, puntahan natin yung relationship sa pagitan ng pressure at saka ng temperature. Paano natin yan i-establish? Madali lang yan. Now, itong gas na ito, i-immerse mo siya sa isang known temperature. For example, 0 degrees. No? So, dito nakalagay ay isang flask or isang beaker na may lamang tubig at saka yelo. So, ina-assume natin they are in thermal equilibrium, no? So, if they're in thermal equilibrium, anong temperature yan? Yan ay 0 degrees Celsius, 'di ba? Yung thermal equilibrium, ang yelo at saka ang liquid water. No? So, anong gagawin mo? We know the temperature of the gas that is equal to 0 degrees. Now, we can measure the corresponding pressure, no? Using a formula, yung rho GH baga sa fluid statics. So now, if we know the pressure and the corresponding temperature, we can actually create a graph, no? We can graph the pressure as a function of temperature. What I'm saying is that gawa ka ng graph para bagang ganito yan. Ayan, no? Ito yung pressure mo at ito yung temperature mo. Alam natin ang temperature dito ay 0 degrees, no? 0 degrees yan, okay? At alam natin ang pressure. So, ilagay mo yung pressure. Kung ano man ang pressure ng gas. Paano nalalaman yung pressure? May formula yung pressure. Depende sa height ng mercury. Pagpalagay natin may nakuha tayong pressure, lagay natin dito yung point. At 0 degrees Celsius, ang pressure niya ay nandito. For example, okay? So, now, anong sunod? Palitan ko ito, no? Gawin ko siyang kumukulong tubig, no? I immerse this flask this time in a boiling water. Na alam ko ang temperature, no? That's 100 degrees. Pagpalagay natin ito 'yon, no? Ito yung T equals 100. Ano ang corresponding pressure? Natural, tataas 'yan. Bakit? Kasi sabi natin pag tumaas ang temperature, tataas ang pressure. So, pagpalagay natin andito siya. Yan. So, now we have 2 points. Now I can connect these 2 points in order to create a graph. So, here we can see that we have a straight line. Kaya nga sinabi natin ang relationship nila ay direct, no? Kung yan ay direct relationship, dapat ang graph nila ay straight line. Okay? So now, if we know any pressure, malalaman natin yung corresponding temperature. O, di ba? O, halimbawa, dito, ang pressure ay may value. Ito yung pressure na nakuha natin. Ano ang corresponding temperature niya? Extend mo lang to, kasi linear yan So, meron na tayong mababasang temperature doon. That's it. That is how you use this thermometer to measure temperature, no? By measuring the pressure variations. Okay, so pagandahin ko lang yung graph ipakita ko sa inyo. Ito siya ngayon. So, we now have 2 sets of point. A point here and a point there. We connected them in order to create a straight line na pwede natin gamitin para mag-determine ng temperature provided that we know the pressure of the gas. Paano malalaman agad yung pressure ng gas? Depende sa height ng mercury doon sa tube. Pag alam mo yung height ng mercury, malalaman mo ang pressure. Pag alam mo yung pressure, dahil meron tayong graph dito, i-plot mo lang yung pressure, malalaman mo na ang corresponding temperature kasi straight line yung graph natin. Now, ang mga scientists, nung unang panahon, nag-eksperimento sila gamit ang iba't ibang klaseng gas. Okay, pinalitan nila. Halimbawa, kanina, ang gas mo ay oxygen. What if palitan ko yan, gawin kong carbon dioxide, no? And I repeat the procedure, no? So, magkakaroon ako ng 2 points. Okay? Now, palitan ko ulit yan, gawin ko halimbawa nitrogen, no? So, I repeat the procedure again. I measure the pressure at 0 degrees and then I measure the pressure at 100 degrees. Natural, iba-ibang gas, iba-iba ang makukuha kong points. Okay? So, pakita natin ngayon dito, no? So, we used 3 gases here, no? Gases 1, 2, and 3. Okay? And we plotted the corresponding pressures at 0 degrees and likewise, the corresponding pressures at 100 degrees. So, we can see that all the graphs are straight lines. Okay? Now, if we will project these graphs on the left side, we will notice that these lines will converge at this point. No? Na-observe din yan ng mga scientists noong una. However, noong mga panahon yon, hindi pa nila talaga nararating yung mga sobrang babang temperature. Pero ang napansin kasi nila, kahit anong gas ang gamitin nila, lahat ng graph ng mga yan ay nagko-converge sa point na ito. Lahat ng graph ng mga gases, kahit ano pang gas ang gamitin nila, nagko-converge. Ano ang ibig sabihin nito? Ibig sabihin yan, kahit anong gas pa ang gamitin mo, no, ito na yung pinakamababang temperature na pwedeng ma-achieve. Paano ko nasabi na siya ang pinakamababa? Kasi itong x-axis na ito, temperature yan, no? Sa graph ng kahit anong gas pa ang gamitin mo, wala akong makukuhang temperature that is lower than this. Ito na yun. That's why they thought that this could be the lowest possible temperature, no? And in addition, no, tingnan mo, dito sa point na ito, kumapal na siya pawiin ko nga. Dito sa point na ito, ano ba ang value ng pressure? Di ba dito ang pressure ay 0? So, kung sa point na ito, 0 na ang pressure, no? Meron bang ibig sabihin kung ang pressure mo magne-negative? No? I can think of a situation in which the pressure is negative. That doesn't make sense. That's why scientists thought that this temperature, kung ano man ito, this is the lowest temperature possible. It so happened na ang temperature na iyan ay may value na ito. Negative 273.15 degree Celsius. And since according to them, this is the lowest possible temperature achievable, then they called it the absolute zero temperature. At ang absolute zero temperature na yan ang ginamit doon sa ating absolute temperature scale. Di ba sinabi ko sa inyo kanina, because of this constant volume gas thermometer, nagkaroon ng isang temperature scale na tinatawag na absolute temperature scale. So doon sa temperature scale na ito, ang panibagong zero ay ito na. No, hindi na 0 degrees, but rather 0, no? Itong panibagong 0 natin ay negative 273.15. Nagkakaintindihan po ba? Yes. Sir, curious ako, no? 'Di ba sinabi mo na ang temperature ay measure ng average kinetic energy ng mga molecules? Yes. I mentioned that in our discussion of temperature. Sir, how can you describe now the energy of the molecules at absolute zero? 'Di ba? Ano kaya ang energy na taglay ng mga molecules sa absolute zero temperature? Nawawalan kaya sila ng energy? Nagiging zero din kaya ang energy? You may think na kung absolute zero, pati yung energy ng atoms at molecules nagiging zero na rin. 'Di ba? Okay. But actually, it is not. Why? Because quantum mechanics tells us that even at absolute zero temperature, ang mga molecules at ang mga atoms ay nagtataglay pa rin ng energy because of what we call the quantum mechanical effects. Okay? So, the proper and appropriate way of describing a thermodynamic system in absolute zero temperature is that nagkakaroon sila ng minimum amount of energy. So, we define the absolute zero temperature as the thermodynamic equilibrium state of minimum energy. Ito po yung state of thermodynamic equilibrium kung saan ang isang given system ay nagtataglay ng minimum amount of energy. Now, let us discuss the absolute temperature scale which was developed because of this gas, constant volume gas thermometer. Anong tawag dun sa temperature scale na yon? Yes, that's right. We call it the Kelvin scale. Okay? So the Kelvin scale, as I have mentioned, is the absolute unit of temperature in the SI system of units. And this is named after William Thomson, who is also popularly known as Lord Kelvin. Kaya siya tinawag na Kelvin scale. Again, that is because in honor of Kelvin. Bakit? Because actually, it was Kelvin who proposed to develop an absolute temperature scale. In this Kelvin scale, ano yung reference temperature natin? Of course, isa na doon yung absolute zero. Okay? Kasi yun yung bagong zero. Okay? Now, aside from the absolute zero, the other reference temperature is not the boiling point of water, not the steam point of water, but this time we have another reference temperature which is called the triple point of water. Water is used because of course it's very abundant and very common. Eh sir, ano ba ang ibig sabihin ng triple point? The triple point of water is a specific condition, okay? The triple point refers to a well-defined condition in which we can see the three states of matter coexisting in equilibrium. So if that is the triple point of water, then there is a particular temperature and pressure in which we can see liquid water, solid ice, and the gaseous steam, no? All existing at the same time in thermal equilibrium. Ang galing, no? Posible palang mangyari yon. Yes! No, that is possible. However, that doesn't just happen at any value of temperature and pressure, no? It happens at a well-defined temperature and a well-defined pressure. Sir, may tanong ako. Ano ba yung value ng triple point of water? Okay, bago ko sabihin yan, ulitin ko muna ha, anong meron sa absolute zero? At the absolute zero temperature, which is now negative 273.15 degrees Celsius, any thermodynamic system has minimum energy. Okay, now, let's go back to the triple point of water. Ang triple point of water, no, that is a specific condition in which all the three states of water can exist in equilibrium, no? And that happens at a defined temperature and pressure, no? Which is 0.01 degrees Celsius and 4.58 millimeters of mercury. Okay? So, sir, may tanong ako. Anong tanong mo? Why was the triple point of water chosen as the reference temperature in the Kelvin scale? Do you know that this triple point of water has the same value anywhere in the universe? Okay, that is the reason why, no? Kahit sa ang parte ka pa ng universe pumunta, ang triple point of water, ito lang ang value. Okay? Kahit sa Mars, kahit sa Pluto, kahit sa Andromeda Galaxy, okay? For as long as in those places, no, the laws of physics that we have here on Earth are also applicable, no? So, hindi nagbabago yan. That is the reason why it was chosen. Again, so the triple point of water is chosen for precision and for reproducibility. Why? Because these values do not change anywhere in the known universe. So now, how do we define a Kelvin? Okay, previously, we define Kelvin as this fraction, 1 over 273.16 of the difference between the triple point of water and absolute zero. Sir, saan ang galing yan? Ganito kasi yan. Ano? So remember, ano ang ating reference temperature dito? Ang reference temperature natin ay, ano nga iyon? Sa baba, we have negative 273.15, no? Celsius yan, ano? Degrees. Ito yung panibago kong zero. This time, Kelvin yan, no? Tapos sa taas, ang gagamitin ko yung triple point, 0.01. Okay? Now, ano ang corresponding value niyan sa Kelvin? Ayan, madali lang, no? Kasi kung ikaw ay Celsius, dadagdagan mo lang ng 273.15, magiging 0 na siya. So, ito, dagdagan ko lang ng 273.15, ang sagot dyan ay 273.16. Okay? At ilalagay natin Kelvins. Okay? Sir, bakit wala kang degree? That is a good question. So, your Celsius and Fahrenheit scales are not absolute units. That's why, laging may degree. Degree Fahrenheit, degree Celsius. But since Kelvin is an absolute scale, ng temperature, hindi tayo naglalagay ng degree. Kelvin lang. So it's wrong to say 273 degrees Kelvin. No, it is wrong to say na may degree ang Kelvin. Kelvins lang. Nakakaintindihan po ba? Okay, now let's go to the definition, no? Itong dalawang ito, pag pinag-minus ko, ay may makukuha akong sagot, 273.16 pa rin, no? Ang gagawin ko, hahatiin ko yan into 273.16 din na equal parts. And one part is equivalent to 1 Kelvin. That's why the definition says that 1 Kelvin is defined as 1 over 273.16 of the difference between the triple point of water and absolute zero. Pero kung medyo matalas ang iyong pandinig, no, kanina nabanggit ko, no, formerly, this was the definition of Kelvin. However, very recently, I think 2019 yata iyon, or if not 2020, binago na ang definition ng Kelvin. Okay? So, that is a reading assignment. Ano? Ano ang panibagong definition ng Kelvin? This one is the old definition. I want you to search for the new definition of Kelvin, which is based on a certain physical constant. Okay? So, may reading assignment na kayo. Ngayon, balikan natin ha. For the sake of comparison, ito ngayon ang absolute zero, yung negative 273.15 degrees Celsius equivalent sa 0 Kelvin, at ang triple point of water, yung upper reference natin ay 0.01 degrees Celsius na equal naman sa 273.16 Kelvins. Okay, paano mag-convert ng Celsius to Kelvins? Madali lang. Kung ano ang reading sa Celsius, dagdagan mo lang ng 273.15. So yung Kelvin, kung gusto mong gawing Celsius, maminusan mo lang ng 273.15. Okay? Now the good thing about Kelvin is that the Kelvin scale is compatible with the Celsius scale. Why? Because the magnitude of 1 Kelvin equals the magnitude of 1 degree in Celsius scale. Okay? So kung magkasing laki pala yung magnitude ng 1 Kelvin at saka 1 Celsius degree, then a change in degree Kelvin would be equal to the change in degree Celsius. Yes, exactly. That's why I said they are pretty much compatible. So makikita natin in later discussions that I will no longer convert Kelvin to Celsius in some calculations. Why? Because these two are compatible. But of course, there are calculations in which you are required to convert Celsius to Kelvins. Okay? That depends on the problem that you are solving. Now, let us compare the temperature scales that we have discussed so far. Let's compare the Celsius, the Fahrenheit, and the Kelvins. Dagdagan pa natin, no? Yung hindi ko nabanggit is yung Rankine, no? Rankine is also an absolute temperature scale, but this is in the English system. So, kumbaga, itong Kelvin ay kakompatible ng Celsius. At itong Fahrenheit, ang kakompatible ay Rankine. Okay? Ganyan sila. So, we can see here the different temperatures of some physical systems. The boiling point of water, human body temperature, 37 degrees, di ba? Freezing point, sublimation point of dry ice, in these various scales. Now, bigyan ko pa kayo ng isa. Ayan. Para magka-idea kayo kung anong temperatura ng mga bagay sa ating paligid, no? The lowest temperature achieved experimentally. Yan, oh. Tingnan mo. This is 10 to the minus 9 Kelvin. This is a billionth of a Kelvin. This is very, very close to absolute zero. Okay? So, there has never been an experiment, no, conducted anywhere in the world as of today kung saan na-achieve ang absolute zero. But we were very, very, very close to absolute zero. Why? Because we're able to achieve this extremely low temperature of 10 to the minus 9 Kelvin, no? However, this temperature is not the temperature of an object which you can touch or which you can see. Yan ay microscopic, ang bagay na pinag-uusapan, no? Yung pinag-uusapan natin dito na may ganyang temperature, 10 to the minus 9 Kelvin, ay microscopic entity. Subatomic siya. Now, liquid helium has a temperature that is close to 1 Kelvin, no? Liquid nitrogen, liquid hydrogen, okay? Water freezes at close to 100 kelvins. Copper melts at approximately 10 cube or 1000 kelvins. Take note that the temperature here is in kelvins. Now, the surface of the sun has a temperature in between 10,000 and 1,000 kelvins. This is the temperature of the solar corona. Okay, take note that the temperature of the solar corona is even higher than the temperature of the solar surface, no? And how about the interior of the sun? Okay? Ano ang temperatura sa loob ng sun? Diyos ko, galing ako doon, no? Pumunta ako sa loob ng sun, sobrang init, nasunog ako. Look at me now, I am so burned. Burnt na ako. Okay. 10 to the 7 kelvins. Diyos ko, alang-alang. And the temperature of the hydrogen bomb, take note, no? Kapag ang isa palang hydrogen bomb ay nag-explode, yung temperature na generate niya is even hotter than the interior of the sun. Yes. Ganyan kainit ang hydrogen bomb, no? So wala na tayo ngayon sa mundo. Tayo ay nasa outer space na kasi ang pinag-uusapan natin is yung interior ng sun, yung solar corona, 'di ba? Now, let's go back to the earth, no? Sa tingin ninyo, ano ang pinakamababang temperaturang na-record sa earth at saan ito nangyari? I will give you the value, that's 184 kelvins, okay? This is the lowest temperature of air ever recorded on Earth. No, kung may mas malamig man na nangyari pa dito sa Earth, hindi na i-record 'yon, baka panahon pa ng mga dinosaur 'yon. Panahon ng siguro ay panahon ng last ice age pa 'yon nangyari. But in modern times, yung na-record natin, no, at nailagay sa mga libro, no, na alam natin ngayon is ito, 184 kelvins, and this was recorded in a place in Antarctica, no, at the Soviet Vostok Station 1 in Antarctica. Okay, how about the temperature of outer space? Do you think it's hotter or colder in outer space as compared to in Antarctica? Saan kaya mas malamig? Sa Antarctica o sa outer space? Actually, the temperature of the outer space, the average temperature of outer space is only 2.7. Only 2.7 kelvins. Ibig sabihin pala napakalamig sa outer space. Yes, it is extremely cold out there. No, that's why we are lucky. We are on Earth. We are being warmed, no, by, of course, the sun. Kung saan nanggagaling yung init dito sa Earth. Now, how about the lowest temperature ever recorded of something that is macroscopic? Kasi ito kanina nabanggit ko, 10 to the minus 9 Kelvin is extremely very low. No, this is very, very, very close to absolute zero. But this is the temperature of something that is subatomic. Now, what if ang pag-usapan natin is temperature ng isang bagay na nakikita ng ating mata, no? Macroscopic siya, no? Anong temperature yung na-record na pinakamababa? Actually, that is 273.144 kelvins. Okay, take note of this, ha. Absolute zero is 273.15. No, ito 'yon. 273.15. Pero yung pinakamababang temperature na na-record, no, ay 270.144 kelvins. Very close pa rin. Okay? Very close. So, I hope you now have an idea of how hot the sun is, no? Baka ngayong kaklase mo, mas hot pa dyan eh, no? Kasi turn on ka sa kanya. Sabi mo, sir, my classmate is even hotter because I am really turned on by him. Charot! Okay, let's move on, no? Iwanan na natin ang kalandian. Punta na tayo sa concept check. Here I have a question. Consider the following pairs of materials. Which pair represents two materials, one of which is twice as hot as the other? So may tanong dito ngayon, itinatanong sa atin kung alin daw sa mga materials na ito ang nagsasabi sa atin na yung isang bagay ay 2 beses na mas mainit kumpara dun sa isa. Okay? Is it letter A, boiling water at 100 degrees and a glass of water at 50 degrees? Is it letter B, 100 degrees Celsius? No? Tapos yung isa naman negative 50 degrees Celsius. Okay? Yung isa naman ice cube, negative 20 degrees. At yung isa naman ay flame, no? Flames from a circus fire eater. Diyos ko po. Alam mo yung nasa circus na kumakain ng apoy? Ayan. Ang flame daw ay 232 degrees Celsius or none of those pairs. So, let us have a few seconds for you to think. Sige, mag-isip ka lang. Sirit na ba? Okay. Isip-isip. Okay. Now, I assume you already have an answer. Okay. If you already have an answer, let me now show you the correct answer. Okay. The correct answer is letter C. The ice cube at negative 20 degrees. No? And this 233 degrees daw ay twice as hot as negative. Sir, paano nangyari yan? Ito 233 degrees. Paano masabing ito, negative 20 ay twice? No? Twice na mas mainit daw ito kumpara doon. Eh obvious naman sir, ito yung 100 twice the value of 50. So kaya letter A dapat ang sagot? No. It's not like that. Bakit? Kapag nagko-compare tayo, when we are comparing the hotness or coldness of two objects, no? Para natin masabi na yung isang object ay dalawang beses na mas mainit kumpara doon sa isa. Tinagalog ko na ha, kinakailangang i-express mo ang kanilang temperature in absolute units. Ah, shit! So, that is why itong 100 degrees Celsius ay hindi dalawang beses na mas mainit kumpara sa 50 degrees. Bakit? Kasi yung Celsius ay hindi absolute temperature unit. So, pag kinonvert natin itong negative 20 degrees Celsius, kinonvert natin yan sa Kelvin, magiging ano siya? So, 273.15 minus 20, edi 253.15 kelvins. Okay, ito naman 233. Yung 233 na yan, kapag ka aking i-convert into kelvins, ay magiging, didagdagan ko ng 273. Right? Pag dinagdagan natin yan ng 273, magiging ano siya? 506. No? 0.15 kelvins. Okay. So, kitang-kita natin ngayon, itong 253, kapag ka minultiply natin ng 2, ito halos yung makukuha nating sagot. 'Di ba? Magkaiba lang sila ng value dito, which is very minimal na. That's why we say that this temperature, no, which is 233 degrees, in kelvins, that's 506.15, is twice as hot as this temperature. Again, when we are comparing temperatures, para natin masabi na siya ay dalawang beses na mas mainit, kinakailangan i-express ang temperature in absolute units. So, dapat naka-kelvins. So, at this point, we've had so much of the concepts. Let us now try to use physics, no, to solve problems. On a day when temperature reaches 50 degrees Fahrenheit, ano daw ang temperature in degrees Celsius at saka in kelvins? O madali lang yan. Yung Fahrenheit, ipinapa-convert lang sa atin into Celsius and in kelvins. How do we convert? Madali lang. What again is the formula for finding the temperature in degrees Celsius? The temperature in degrees Celsius, if you recall, is the temperature in Fahrenheit, maminusan mo ng 32 at imumultiply mo ng 5 over 9. Di ba ganun yan? Substitute natin ha. 5 over 9 times. Ano ang temperature in Fahrenheit? 50. Minus 32. So, 50 minus 32, that's 18. 18 over 9, that's 2. Times 5, so we have 10. So, this temperature is equivalent to 10 degrees in Celsius. Okay? How about in kelvins? O, madali lang. The temperature in kelvins equals this value plus 273.15. So, that will give us 10 plus 273.15. This gives us 283.15 kelvins. Okay? So, that's it. Madali lang siya. Okay? So, ngayon, turuan ko kayo ng calcu, no? Calcu method. Pwede rin kasi nating idirekta yan sa calcu, no? So, I'm gonna show you an emulator of a calcu that is commonly used by engineering students. Ito rin yung itsura nung 991ES na calculator. Yun lang 991ES, meron lang siyang solar dito. But overall, yung functions, they're just the same. Okay? So, how do we convert? If you want to convert Fahrenheit to Celsius, we will use the convert function. No? You input the value of the temperature in Fahrenheit, so 50. And then you choose the convert. No? Shift, convert. Ayun, shift, convert. Okay? So, yung Fahrenheit, para maging Celsius, 37 yan eh. No? 37. Okay, check natin. Ayan, no? 50 degrees Fahrenheit to Celsius is now equal to, that's it. Ayun, 10 degrees Celsius. Diba? Madali lang. Okay, shift convert, 37. Tapos kung gagawin mo siyang kelvins, dagdagan mo na lang, 273.15. Diyos ko, kinalcue pa, plus 10 lang naman, di ba? Ayan, parehas na sila, 283.15. O, di ba? Madali lang. Now, let us solve another problem. Iron melts, ay, natunaw yung iron, no? Iron melts at 1811 kelvins. Okay, 1811 kelvins. What is its temperature in Celsius? And what is it in Fahrenheit? Madali lang, no? Para yan ay makompute natin, i-calculate ko na lang ha, para madali, no? Yung 1811, maminusan ko lang ng 273.15 para maging Celsius. So the value is 1537.85. T C is equal to 1537.85 degrees Celsius. Ayan, para madali, i-round off mo na lang. Mga 1538, di ba? Tandaan mo yan ha, that's the melting point of iron. Now, what is this temperature in Fahrenheit? Gawin na lang natin yung rekta, no, sa calculator. Ano nga 'yon? So, ito na yung answer natin, di ba? Okay, i-easy ko lang yan ha. Tapos pinutin ko answer. So, yung sagot natin kanina, ito siya. Yung answer na yan, convert ko into Celsius. Using the convert function. You shift convert, this time 38. No? Kung Celsius, gagawin mong Fahrenheit, 38 yan. No? Ayan. The answer kanina, which is 1537.85 in degrees Celsius. Now, in Fahrenheit, that's equivalent to, ayan, 2,800.13. T in Fahrenheit is 2,800.13 degree Fahrenheit. Let us check if that's correct, no? Paano nga mag-convert ng Celsius to Fahrenheit? Okay, ang gagawin mo lang 32 and then plus 9/5 ng temperature in Celsius, which is 1537.85. Okay, kalkuhin natin 'yan, no? 32 plus 9/5 times 1537.85. Okay, so we're able to get the same answer, 2,800.13, which is now in Fahrenheit. Okay? So, that's it. Marunong na kayo ngayon mag-convert from one temperature scale to another. Okay, so that ends the topic for this video. Okay, so in the next topic, ang i-discuss ko naman sa inyo is thermal expansion, no? Ano ang nangyayari kapag ang isang bagay ay uminit? Siya ay nag-expand. At pag siya ay nag-expand, of course, nagbabago ang kanyang dimensions. Okay? So watch out for that video. Thank you. Bye!